Hey y'all! In this video I'm going to introduce the Moulding Toolpath, and I thought a good place to start would be on a simple project like this radiused guitar fretboard. Some of you may be thinking that's not a very simple project, but when it comes to the Moulding Toolpath, creating this radius on the top surface is a very simple project to do. Now let me preface all of this by saying that I am not a luthier. I'm what you call a hack guitar builder. So if you're interested in lutherie and want to get into serious guitar building, I'll put some links in the description to a couple of message forums that I've found. I would recommend you join those forums, read a bunch of threads on the guitar builds that they're doing over there, and investigate further on your own. I am not an expert at this at all. Also, let me say that there are many ways of making fretboards. This is not the right way, it's not the wrong way, it's just the way I do it. So, with that in mind, we can go ahead and get going on it. Probably the hardest thing to do on any kind of a fretboard build is to make the calculations needed to lay out the fret marks. The easiest way I have found is to use a website called FretFind 2D. FretFind 2D does use Flash, and I know a lot of people don't like Flash, but you can use it without using Flash. It's just you won't be able to download the vectors we need to do our fretboard. Without getting super technical into guitars or guitar building or anything, you do need some information to lay out a fretboard. First of all, we're going to be working in inches. The main information you're going to need is your fundamental scale length. The scale length is the distance between the nut up here, where the strings cross over from the headstock and the tuners up here, from where the string last touches the nut up here, down to here where the string first touches the bridge. It's this distance in between here, these 2 points, that make up your fundamental scale length. You'll see it's already set for 25 inches. Most electric guitars are somewhere around the 25-inch range. Fender runs 25.5. Gibson, there's some controversy there. They're a shorter scale length. Most people these days, if they're making a Gibson style guitar, it's 24 5/8 of an inch. But most of your Stratocaster clones, etc., are somewhere around a 25-inch scale length. So that's what I'm going to use. Now, if you look at this diagram here, obviously the 6 black lines are the 6 strings. The blue lines out here on the edges are actually the border, the outside perimeter of the fretboard. And the red lines represent the frets. What you'll need to know is your scale length and the width, the string width between this first string here and this last string here at the nut. Now it's already set for 1 3/8. I'm going to leave it there. And then you'll also need to know the width down at the bridge down here. It's already set for 2 1/8. I'm going to leave that alone. Your fretboard overhang is the distance between the outside edge of the fretboard and this first string as measured from the center of this string to the edge of the fretboard. And the same over here, from the edge of the fretboard to the center of the last string. That's already set. I'm going to leave them alone. Then you'll also need to know the number of frets you're going to cut for. Depending upon the body style that you're going to be using, not every guitar can handle 24 frets. The cutaway up here is not big enough to allow you to reach 24 frets. Personally, I'm going to make this a 21 fretboard but I'm going to enter 22 here so that I can use the last fret marker here as the heel end of my fretboard. You'll see this just updated and it took off those last 2 frets. Also, if you were to change the scale length up here, let's just say for instance I wanted to make a custom scale length and I wanted a 24-inch scale, watch the drawing over here when I change this to 24 and then click off of that box. The fretboard got slightly wider. The frets didn't change position, but this distance from here to here is now 1 inch shorter than it was. And you may have noticed the numbers over here changed. Now I'm going to change it back to 25, and you can see all of that changed. Click off. The fretboard got a little narrower as it got longer, and all these numbers over here changed. Now if you don't activate Flash, you can come down here and take all these measurements and use those to calculate your fret positions. If you do activate Flash, allow, you'll see these buttons appear. Once I have all of my measurements over here, change that back to 22. Once I have all my measurements entered over here and I'm sure everything is correct, I can come right up here to this button. Save DXF file to disk. And that's what I'm going to do. I'll navigate to the correct folder. I'm going to name it the same thing. I'm going to replace this file. Save. Yes. Now I'm finished with this website. And I'll put a link to FretFind 2D down in the description box below. Okay, with that drawing now saved, I can go into a new session of Aspire and I can create my pattern to do the fretboard. So we'll go up here to create a new file. I have already done this once before, so a lot of the measurements are already entered for me, but I will go over them again. Also, even though I'm using Aspire version 10, this can be done in exactly the same way in VCarve Desktop and VCarve Pro. So we'll get started with my blank piece of material. I'm going with a 24-inch width in X, a 3-inch height in Y, and my material thickness is 1/4 of an inch. I am using inches. I'm setting my Z0 at the material surface. For layout purposes, I'm going to set my XY datum position to the center. However, I will be changing that over to the bottom left, as that's where I set my XY0 outside on the CNC machine. And we'll go ahead and we'll accept those settings in our job setup. Okay, now I'm going to need to import that DXF file. So I'll go up here to File, Import Vectors. Navigate to the folder I want to import from, and here is my fretboard. So I'll select that and open it. And that's the orientation that it saves the fretboard in. So with everything selected already in pink, I'm just going to tap the number 9 on my keyboard. And you see it rotates it 45 degrees. I'll tap it again. And there we have rotated it 90 degrees. I can come over here and align it vertically and horizontally with the center of my material. And that brings it down here where we can see it. Now you can see already that this is way too long. It's about 1 inch longer than the material is. If you remember when we were over in the website, I said that this measurement from this line right here down to the end here is from the nut to the bridge. Well, we're not interested in all of that. We need from the nut to this line right here. So I can click off to deselect, and I can grab my scissors, and I can trim away this outside vector here and this outside vector over here, then close. Now the rest of these vectors here represent the guitar strings, and I don't need those for this drawing. So I can select all of those and just delete them. Now I have just my fretboard vectors that I'll be using. So I need to center those on my material. So I'll select them all and align them vertically and horizontally with the center of my material. Then close. Because this was a DXF file, and knowing the way DXF files are created, we know that these are not joined vectors. Also, because of the way that website works, it can make multi-scale fretboards. All of these fret lines are separate segments. So I will need to join these. So what I'll do is I'll select them all, then holding down Shift, I'll deselect these edges here. Then I want to join all these vectors. So I'll come over here to join. And you'll see my tolerance. I have reduced my tolerance way down to almost a 1/2 inch. So I can get all of these vectors joined. If it were back at regular tolerance, the tolerance is so close, it's not selecting any of these vectors to join them together. So I just kind of backspace to get rid of a 0. Now it'll join some of them, but not all of them. Get rid of the other 0. And now I know that it'll join all of these into solid vectors here. So I'll click on Join, close that. Now if I come over here and select one of these, it selects the entire vector. Those are no longer individual segments. Now to create the outside profile of my fretboard, I'll need to join the two sides with the two ends. So, before I can do that, let me grab my trim tool and zoom in a little bit, and you can see that these vectors overhang these edges just a little bit. I need to come up here and I need to trim this one. Come back up and trim this one. Then go up to the ends, other end rather, and trim this one. Then trim this one. I can close that, zoom back out. I don't need to trim the overhang on the fret markers themselves because I'm not going to be trying to join them to the sides. They're going to stay individual open vectors. With that trimming done, I can now select that and it's joined automatically. So that's now one closed vector. Now this is something that's optional, but it's something that I want to do. This is the end of my fretboard here, and I don't want this square 90-degree corner. So I'm going to come back over here under Edit Objects to my Fillet tool. I want to put a 1/8 inch radius on these corners. So I'll come up in here and you'll see how my cursor is changed to that fillet with the little plus sign. I zoom in and I bring it up into the corner and you see a little check mark appears. That's telling me that this corner can be filleted. So I'll just click, come down here until I get the check mark, click, and I've rounded off my corners. Now I can close it, and there is the final shape of my fretboard. I could do some more sculpting, but for this demonstration I'm not going to worry about it. I do want to keep these nice square corners down here because this is the type of fretboard that the nut is glued down to the neck right here at this edge, flush with this edge of the fretboard. Okay, now we'll get to the molding toolpath. To mold in this radius over the top of the material here, it uses two vectors. I need a drive rail and I need a profile. The profile is the shape that I'm going to mold into the top surface of this material. And the drive rail tells the program which direction and how much of this material I want to project that profile down. We'll start with the easiest vector that we'll need to draw, and that is just a straight line. And so I'll come up here to draw a line, polyline. I don't want to mold the entire top of this material. I want to be able to fasten it to my spoil board, and there's no sense in it running out here and machining away material that I'm not going to be using for the fretboard. So I'm going to come out here along this bottom edge of the material. I'm going to come out here roughly an inch away from the end of the fretboard, and I'll click to start my vector. I'll come out here to about an inch away roughly from the end of the fretboard, still on that bottom edge of the material, and click again to end my line. Then I'll hit the space bar to end that line. Now you can't see it because it's right on the edge of the material, but if I were to draw a box, you can see how that drive rail lines up with the bottom edge of the material. We're going to use this vector to tell Aspire or VCarve that this is the line we want our profile to follow. So let me click off to deselect that, and now we'll draw our profile. The profile is going to be a simple profile. I'm going to radius this fretboard, and there are several common radius measurements people use. Most common is 9-inch, 12-inch, or 16-inch, depending upon how flat or how rounded you want that fretboard. I'm going to go with a 9-inch radius. That is typical of most electric guitars. To do that, first of all, we want to make a rectangle that's the same width as our material is high in Y, and the same thickness as our material. So I'll go over here to draw a rectangle, and again, since I've already done this before, the width is already set, 3 inches, and the height is already set, 1/4 inch. So now I can just come out here somewhere away from the material. I'll bring it down here to make it easier to maneuver, and I'll just click. Then I'll close, and that draws me a rectangle that is 3 inches wide, the same as the width of my material here, and 1/4 inch tall, which is the same as my material thickness. Now I want a 9-inch radius up here on this rectangle. And the easiest way to do that is to create a circle. Make sure my radio knob is over here in radius, and the radius of the circle I'm going to draw is 9 inches. I'll come down here and just click. Now I can close this. Now I want to move this circle down and align it so that the center up here, the top of this circle in the center, is matched up with the center of this rectangle. Now because I have smart snapping enabled, I can just come up here and you'll see how my cursor changes to that crosshairs with the 4-way arrow. I can just click and hold, drag it down to where that is touching the top line, and it just snapped right onto the top line of that rectangle. Then I can grab it again, click, and drag it over and we'll get it to snap. You see how that cursor changes? It's now indicates a center mark. And I can let go, and now the center of that circle, the center of this edge of the circle is in the center of this rectangle. Click off, and I have the circle overlapping this rectangle, and the center marks of each vector are lined up right here. Now I can start trimming to make the profile. So I'll grab my trim tool. The first thing I'll do is I'll get rid of the rest of this circle because I don't need it. Then I can come up here and I can trim away that corner of the rectangle and that corner of the rectangle. I can now close the trim tool, and because I have a check mark here in Rejoin Trim Sections, when I close this, it has automatically closed this vector. Okay, there's one more thing I need to do to this to make this a profile I can use with the Moulding Toolpath. That is, I'll need to eliminate this vector down here on the bottom. So I'll go into Node Editing mode by typing the letter N on my keyboard, then bring my cursor right up here over this vector, and you see how that little tilde appears underneath the arrowhead. I'll right-click, delete span. And that removes that vector down below. Now I can click off to deselect, right-click to come out of Node Editing. Then there is our profile that we're going to use along with that drive rail to radius the top of this fretboard. So let me go ahead and select it, click it again to go into Move and Transform mode and bring it up here a little bit closer, so I don't have to hunt around to try to find it. And I'll zoom in. Believe it or not, we're already ready to calculate the toolpaths needed to cut this fretboard. It's that simple, as I said. So we'll go over here to the Toolpaths tab, and the first thing I want to do is radius this fretboard. So I will select that drive rail and hold down Shift, select the profile. The drive rail first. You can use more than one drive rail if you should need to, but always select the profile that you're going to drive along this rail. Select that profile last. We'll go over here to the Moulding Toolpath. And the Moulding Toolpath up here in this paragraph will remind you to do this. Select the drive rails for the toolpath, followed by the profile you wish to extrude. You can use multiple rails. The last selected vector is the profile. So when we opened up the Moulding Toolpath, we see that our drive rail turned orange and has these little arrows here. And so did our profile. It turned orange and has the little orange letters. It also shows the start point for both the drive rail and the profile. But you notice these red projections down here. These red projections are showing us that it's going to extrude this profile out here. Well, we don't want it to do that. We want it to extrude back up here in this direction. So to change this, we'll put our cursor over the drive rail and right-click, then select Reverse Direction. It has now corrected itself to where our profile is going to be extruded this way across our material. So now we can move over here to the next section. Gap above our toolpath. We don't have a gap above our toolpath. We want it to start carving from the surface. So now we'll choose a tool. I'm going to use a 1/4 inch ball nose. Select that. Then I'm immediately going to edit it because I want to bring my step over down, but only for this toolpath. If I were to change this step over when I selected it, it would save this setting, and every time I selected this bit, that change step over would be the default. I don't want to do that. I'm going to bring this down to about 8%. I want a real small step over so I get a fairly smooth finish. There will still be some sanding involved, but I'd like to have the smoothest finish I can get. My inches per minute, I can bring that up, my feed rate, and I can take that to 40, just for giggles. And we'll click OK. I am not going to use a larger area clearance tool, but do know that we have that option if you're doing a complex molding. I don't need to worry about creating sharp corners. A boundary offset, if I was carving within the edges of my material and I needed to make certain that that tip of that bit went past the edge of my material, I could enter a boundary offset equal to the diameter of the bit that would bring the tip of that bit out past the edge of the material, 1/4 inch, just to make sure that this entire edge got machined. I don't need to worry about that because I will be cutting out the outside profile of this. So if the tip of the bit only gets up to here, I'm fine with that. I'll be cutting this out. I am going to change the name of this toolpath to Fretboard Radius, and we'll calculate that toolpath. There's our toolpath calculated. I'll go ahead and preview it, and we see the bit is going to start low here, come up to almost the surface of the material, and then start back down the other side, giving us a nice radius carved into the top of the fretboard. Go back to a straight Z view, close my preview window, come back over to the 2D view. Now the way I cut fret slots for the fret wire, I still cut my fret slots by hand. So all I'm going to do is use a 30-degree V-bit to score a line in the top of the fretboard right here in the center. So I have an indication of where I need to line up my fret saw in my fretting jig and cut those fret slots. So I'll select all of these fret markers and I'll do a profile toolpath. I want my cut depth to be about 20 thousandths, so 0.02. I don't want it to cut very deep at all, but deep enough for me to see those lines after I get finished sanding down that fretboard. I don't want to sand away my markers here. I want to machine on the vector. I'll catch that before I forget it. Now I need to select my bit. I'm going to use a 1/8 inch diameter 30-degree V-bit. Give me a real fine line. So I'll select that. Again, I want to make sure I'm machining on the vector, and I don't want to make any changes down here. Name this fret slot and calculate that toolpath. Then we'll preview that, and there we go. Now I know it looks like it didn't cut them all, but as you zoom in, it's just simply the way the preview is shaded. When you zoom in, you can see those little fret marks. Again, I cut with a hand saw. I prefer to do it by hand, and this just gives me an index line where I can set up my fretting jig and cut these fret slots with my fretting saw. So we'll close our preview. And now all that's left is my profile cutout. And again, I'll select the vector I'm going to cut out, go up to a profile toolpath. This time I want to cut all the way through the material, so for my cut depth, I'll type in Z plus 0.005 because I want it to cut about 5 thousandths through the material to make sure I cut all the way through, and tap equals. To cut out the tool, I'm going to use a 1/4 inch end mill, and I'm going to machine to the outside of those vectors. I do want to do a separate last pass with an allowance of 0.01. I'm not going to add tabs. This is a perfect candidate for my masking tape and CA glue method of mounting it to the spoil board. I am, however, going to ramp in my plunge moves using a smooth ramp over a distance of about 2 inches. I can change this to profile cutout. We'll calculate that tool path. I'm getting the warning that it's going to cut through the material. I want it to. Then we'll preview that tool path. And there we go. Double click to remove the waste material. And there's our fretboard. We have a nice radius. There will still be some sanding involved. And again, that's why I cut my indicators, my fret indicators, 20 thousandths deep. So I can sand this and not sand away my fret marks here. Now, some of you may be asking why I don't just go ahead and machine those as fret slots. With Aspire, I can do that because I have 3D modeling capability. With VCarve Desktop and VCarve Pro, these lines will not cut deep enough to cut fret slots. Now, let me go back into our fret slots toolpath here. And some of you may be wondering why I don't select Project Toolpath onto 3D Model. Well, I will. Then we'll recalculate. And I'll reset my preview, and I'll run these two toolpaths, preview visible toolpaths. There we are, cutting the radius. And then there we go, cutting those fret marks. They still don't project down. The Moulding Toolpath is not considered a 3D toolpath. So this is not a 3D model. So VCarve, and in my case Aspire, even though I selected project it down onto 3D model, the software says there's no model here to project it down onto. So, we'll close this without changing it. Go back to a straight Z view. So, what I would need to do in VCarve Desktop or VCarve Pro is I would need to somehow model this radiused fretboard in another program, then import it into VCarve in order to get these fret slots. This is one of the reasons why I prefer to just make those little markers and then come in with my fret saw and cut those fret slots myself. That's the important point to take away from this. The Moulding Toolpath is not considered a 3D model. It's a 2.5 dimensional carving. If I were to go back over to my drawing toolpath, or drawing tab rather, go into my modeling tab, there is nothing there. We'll go ahead and end it here. I hope you got something out of this video. Don't forget that today at noon Pacific, 3 p.m. Eastern, I will be doing a live Q&A session on everything I've covered in today's video, the molding toolpath, and if you'd like, about cutting fretboards. The main takeaways from this will be the drive rail that's needed, the profile that's needed, and the fact that this is not a 3D model. It's simply a swept profile toolpath. Again, I'll be doing a live Q&A today at noon Pacific, 3 p.m. Eastern, here on my YouTube channel. I'll take your questions live, so I hope to see you there. If you're not subscribed to my channel, now would be a great time to hit that red subscribe button down here and click that little bell right next to it. Then you'll get a notification each time I post a video and when I go live. So once again, I hope you got something out of this video. And as always, whether you subscribe to my channel or not, I'd like to thank you very much for taking the time to watch, and y'all take care.